In this video, I'm going to talk about polynomial division, which just means we're dividing one polynomial by another polynomial. And before we do some examples of that, let's first go back to an example of long division. This is from grade school. You'd have to divide a larger number by a smaller number using long division. And we're going to do this because it's the same algorithm here in algebra. It's the same steps. All right. So the steps for this, first you want to see, does this number out here, does it go into 2? Can I divide 5 out of 2? No, that's too small. I can't even divide it out of there once. So I would go to the next digit here, 28. Can I divide 5 out of 28? And the answer to that is yes. I could do 5 times 5, and that would give me 25. All right. And so we're just going to subtract that from the top to see what the remainder is. 28 minus 25 is going to be 3. And then we just bring down the next digit. Right, so 37 is next. What can we divide out of 37? That's a multiple of 5 would be 35, would be the biggest multiple of 5 that we can divide out of that, or really subtract out of that. So that's going to be 5 times 7 would give me 35. All right, so now I can subtract these. 37 minus 35 is going to give me 2. And then we just bring down our last digit, the 0. And so how many times can I divide 5 out of 20? That's going to be 4. 5 times 4 is 20. And you can tell if I subtract that, I'm going to get a remainder of 0, which is good. So this is not a fraction or a decimal or anything. Your answer would just be 574. So I go over that because when we look at an example here in algebra where I'm finding the quotient, it's really just the same steps. So I would start by just writing this. I'm dividing n plus 5 out of this polynomial. All right, so my first step here is, what do I have to multiply this first term by to make it look like this first term? So here I have an n. This is an n squared. I would have to multiply that times n, right? N times n is n squared. So that's what I'm going to do for this. N times n is n squared. And 5 times n is 5n. All right. And just like before with the long division problem, I'm just going to subtract this from the top. And I like to put parentheses in here because it reminds me that I need to distribute the negative sign. So n squared minus n squared, it's just 0. That's going to cancel out. But 10n minus 5n is going to be 5n. And we just bring down the next term. So 5n plus 18. All right, and we're just going to repeat that same algorithm, that same set of steps. So what do I need to multiply this by to make it look like the first term? So this first term is n. This first term is 5n. So if I just multiply that times 5, multiply times 5, then it's going to give me this, which will cancel these out. So n times 5, 5n, which is what we want. We want these to cancel out when we subtract them. And then 5 times 5 is 25. All right, just like before, I'm going to subtract this from the piece above. So 5n minus 5n, those will cancel. And then 18 minus 25, that's going to give me negative 7. Okay, so the quotient here is n plus 5. But we do have a remainder. We have a remainder of 7. So the way that I'm going to write my final answer is I'm going to first write the quotient, n plus 5. And then I also need to write in the remainder. So the remainder is a minus 7 over what I'm dividing by, over this. But I started with n plus 5. And this is actually the same way you would write a remainder in long division. right? So that's going to be our answer. Okay, so this one is a little more difficult because you might notice here we're missing a term. We have an x squared and then just a number. There's no just an x term here by itself. So like in the last problem, we started off with an n squared, an n term, and then the number. So here we're missing a term, which just means that I need to put in a placeholder. So there is no x term. I'm going to put in a 0x. And I have to do that because otherwise I'm going to run into trouble later when I'm going through the steps. I'll be missing kind of a place. And then our next number here, just bringing that down, is negative 33. Okay, so I'm going to do the same set of steps that I did before. Just notice you have to have that placeholder, that 0 term in there. Otherwise, it's going to tangle up your steps here. So what I'm asking myself is, what do I need to multiply this first term by to make it look like this first term? So here I have 7x times what is going to give me 42x squared. So I could do 6x, right? 7 times 6 is 42, and then x times x is x squared. 42x squared, and then 7 times 6x is going to be 42x. All right, so now we're going to subtract this from the piece above, just like last time, and I'm going to put parentheses here just to remind myself that I'm subtracting both of these. So these are going to cancel, 42x squared, and this is going to give me negative 42x, because I'm doing 0 minus that positive 42x, and then I just need to bring down the last term, that minus 33. All right, so from here, I'm just repeating that same algorithm, that same set of steps, and that's just what do I need to multiply this first term by to make it look like this first term. Here we go. If I multiply by negative 6, that's going to give me minus 42x. And then 7 times negative 6 is negative 42. Right? And I'm subtracting this from that piece above. So negative 42 minus minus, that's going to be a positive, is going to cancel. And then negative 33 minus negative 42, this is negative 33 plus 42 is going to give me a positive 9. All right, so that's going to be my remainder, and this is going to be my quotient. So my final answer is just going to be 6x minus 6, and then plus the remainder, which was 9, over what I'm dividing. So 7x plus 7. All right, hopefully you guys can read that. My tablet's not here. I'm trying to do all this with the mouse. It's very difficult.